This is Mr. Lawrence here, and today we're going to learn the quadratic formula. Now, you got to learn this before you can use it. We're going to use it to solve quadratic equations. But the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Come on, Ellie, sing along. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you get this down, hey, wait a minute, Bradley, you weren't singing. One more time. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. If you get this down, what's that, Andrew? Sure, we can sing it one more time. Okay, here we go. You might want to try to write it as you sing it. It'll help you remember. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Anyway, before I was so rudely interrupted by your request to sing, what, Gotham? Okay, last time, and then we got to get on with the lesson. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, you've got to know the formula, otherwise you can't do the problems. Now, we remember back how to factor, I hope. You know, you'd say, hey, let's see, that's a 1, so I can list the factors of 6. Right? Normally I'd have to list the factors of both. And I know I'm going to add my two factors of 6 to get 5. And so my factors of 6 are 1 and 6. Well, 1 plus 6 is 7. 2 and 3, hey, 2 plus 3 is 5. So I could break this down as x squared plus 2x plus 3x plus 6, right? I rewrote the 5x as 2x plus 3x, and then I could group. And I love factoring, I really do. I think factoring is one of the coolest things ever. The problem is it doesn't work all the time. Let me see, I'm going to GCF this first group, x times quantity of x plus 2, and then I'm going to pull out a 3, right? Okay, and then I have one more GCF to do. I have an x plus 2 that's common to both groups. When I pull an x plus 2 out of here, I'm left with an x. I pull it out of here, I'm left with a 3. And now I can solve. I can say x plus 2 equals 0. Therefore, x equals negative 2. And I could say x plus 3 equals 0. Subtract 3 from both sides to get x equals negative 3. And those are my solutions. If I put negative 2 in for x, use the order of operations, I will get 0. If I put 3 in for x, I will get 0. Like I was saying before, the factoring doesn't always work. A problem like this, we would have said was prime in the past. We've said it's not factorable, and it's not. That doesn't mean it's not solvable. We can still solve it. You see, what we're actually solving for are the places where our graph, and you don't know what the graph looks like yet, where our graph is going to cross the x-axis. Now, of course, they might cross at whole numbers or integers like negative 2, negative 3. But then again, couldn't it cross at x equals 2.169843, right? The quadratic formula is going to allow us to find when it crosses at a strange number like that. Okay, so the first thing I'm going to do in using my quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. First thing I'm going to do is find a, b, and c. I'm going to list them out. A, b, c. Easy as 1, 5, 2. See? 1, 5, and 2, right? A, b, and c. Okay, so now I'm going to go to the quadratic formula. X equals negative of b plus or minus the square root of b squared minus 4ac all over 2a. Now you notice that I use parentheses whenever I substitute in. When my values are positive, it's not such a big deal, but when they're negative, it can be. So make sure you use the parentheses. All right, so now I'm going to simplify this, and I'm going to work inside out following the order of operations. So I do nothing with the negative 5. Inside the square root, I'm going to do the square first. I'm going to get 25. Now I'm going to do negative 4 times 1 times 2. I believe that'll be negative 8. Okay, 2 times 1 is 2. And now I'm ready to simplify a little bit more. I'm going to have x equals 5, negative 5, excuse me, plus or minus the square root of 25 minus 8 should be 17 over 2. All right, now we have two exact answers here. One of the answers is x equals negative 5 plus square root of 17, all of that divided by 2. Oops, I said 17 and I wrote 12, and I'm sure Andrew would come in tomorrow and tell me how funny that was. And or the other place it's going to cross, x equals negative 5 minus the square root of 17 plus divided by 2. Okay, I just heard the bell, so that means you little lovely students are coming to class. So I'm going to pause this video and I will be back with you third period. So Mr. Lawrence saying, hold the bus. Okay, I am back. I don't remember anything I was saying, but here's my work. Oh, yes, I got these exact answers, okay? Now, I can get the approximate answers. I'm going to require both of you, both of them from you. So we've got these, and then we're going to do, oops, I'm not in draw mode, Mr. Lawrence. X is approximately equal to, or x is approximately equal to. These are irrational numbers, right? Irrational numbers. There is no square root of 17. We can do a decimal approximation. It's an irrational number. If it's under the square root, it's got to be some type of perfect square so that we can take the square root. We really can't take the square root of 17. We can estimate it. And we'll talk a little bit about estimating it before the OAA because it's an important skill. But let me get my graphing calculator going here. And it's going to take a minute, so you feel free to discuss amongst yourselves. Would you rather live in the ascendancy of a civilization or its decline? Go ahead, talk amongst yourself. I'm going to pause the video while this is opening. Okay, I've got my graphing calculator up. I hate to interrupt your discussion. I'm sure it was very lively. Now we had plus negative 5. Was it negative 5? Let me double check. Yeah, it's negative 5. So negative 5 plus the square root of 17 divided by 2. You cannot type it like this. This is wrong. Do not do this. Negative 5 plus square root of 17 and then divide by 2. This will not yield the correct answer because I am not dividing the square root of 17 by 2. I'm dividing both the negative 5 and the square root of 17 by 2. So when you go to type it, you want to do one of two things. I like to do a parenthesis for my numerator. Put everything in parentheses. And then you just have to be careful. You want to close the parenthesis on the 17, and then you want to close the parenthesis that you started for the numerator, and then divide by 2. And when you do that, you will get a negative for about 0.438. We'll go with that as an answer. I'll show you the other way to do it in a second. So one answer was negative 0.438, and that's a rounded answer, of course. But don't just assume the other one's going to be positive of it. It's not. Before I do the other one, I'll show you the other way to type this. So you could go negative 5 plus the square root of 17, get your answer, and then divide by 2, and then notice I get the same exact answer. Okay, now a cool thing is you don't have to do a lot of extra typing with these calculators. If you hit second enter, or on some calculators just the up arrow, it'll bring up old problems that you typed in. This problem here is this one, right? So what I'm going to do is I'm just going to arrow over, and I'm going to change that plus to a minus because remember I had negative 5 minus the square root of 17. And so I'm going to change that to a minus, and then I'm going to hit enter, and there's my other solution. Notice it's not automatically one positive, one negative. What is it? Negative 4.562. Okay, so the other answer is, where'd we go? Negative 4.56, and then 2. And there we go. That's what the quadratic formula can do for us. There's no way we could have factored this problem, but the quadratic formula can solve it. Now, remember a problem like this, if you tried to factor it, we said this was prime. There was no perfect sum of perfect squares. I can go the quadratic formula. It's been a while since I sang it. I know you just heard it, but I want it to be stuck in your head so that you're like singing it at breakfast and your dad goes, "What the heck is that song?" X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get to this problem. I'm not going to factor it. I'm going to use the quadratic formula. I got to remember it's a, b, c. Easy as 4, 0, 25. Some of you were thinking this was 25. It's not. Just like standard form. ax plus by, oh, excuse me, yeah, equals c. Well, it's ax squared plus bx plus c. There's no bx term here. There's no x term. It's 0 x's in here. All right, there's an x squared term, and that's a. The x term is b. The c term is the constant, the one without a variable. So now I set up my quadratic formula. X equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. Oh, 2 times 4, not 2 times 8. Sorry about that. Okay, there we go. All right, now this 0 is inconsequential because if I do 0 plus the square root or 0 minus square root, I still get the same number. So I'm going to simplify this to plus or minus the square root. 0 squared is 0 minus 16 times 25. Off the top of my head, I don't know that, but 25 times 4 is 100. I'm thinking 400. Yeah, I think 400 is a good answer there. Okay, 400. And so that'll be over 8. And so the x is going to equal plus or minus the square root of negative 400. That should send off some warning bells. Danger, danger, Will Robinson. Whoop, 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 whoop. What's the square root of negative 400? You don't know. There isn't one. This is an imaginary number. You cannot take the square root of a negative. You can take the negative of a square root, but not the square root of a negative. So if I do the square root of negative 400, I get a non-real answer. Yeah, it's an imaginary number. So in this case, this problem has no solution. Okay. Now what that really means is that when I go to graph it, which we're not doing yet. When I go to graph it, this will not touch the x-axis. Remember that these solutions are the places where the graph will cross the x-axis. Okay, let's go on to this one over here. I got a, b, c. Easy as 4, negative 56, 49. And I'm going to plug it into x equals negative of b. If you don't understand that, b was negative 56, so I need the negative. It's positive. Plus or minus the square root of b squared minus 4ac all over 2a. I did it again. There we go. Okay, so now we're going to do some simplifying. Time to simplify. We're going to have 56 plus or minus the square root 56. Negative 56 squared. Well, 56 squared is 3,136. Minus, I know that this is going to be a negative because there's only one negative in the multiplication. 16 times 49, 784. The whole thing is over 8. X is going to equal 56 plus or minus. Some of you might be wondering, hey, should I divide the 56 by the 8? I'm not going to because I got to remember the 8 won't be gone. It'll still be under this, whatever this is. It might come out to a whole number. In fact, in this one, I think it will, or possibly an integer. But for right now, I'm going to leave it as is. So I need 3,136 minus 784. And so I'm going to get 2,352. And from there we go, x equals 56 plus or minus, and I'm going to take the square root of that, 2,352. Uh-oh, something's bothering me here. It's not coming out nice. I wonder if I have a silly mistake. Oh, I guess I don't. 14, 28. Yeah, I do have a mistake, but that's okay. I can still do it. I wanted it to come out pretty. It's not going to, but that's all right. 48.497. I'm going to the thousandths place. Okay, and so I'm going to get two answers. X is going to equal 56 plus 48.497 divided by 8. So X is going to be approximately equal to 13.062, or X is going to be approximately equal to 56 minus the square root number, divided by 8, and I get 0.938, and that's a rounded answer. Okay, I only gave the decimal approximations there. I didn't give the exact answers, but that's okay. We'll talk more about exact answers and when to use them and when not to. All right, so that is your equation for Friday's lesson. I'm going to get this posted Wednesday, I hope. Mr. Lawrence signing off. Have a good night, everybody.